Hello everyone, I am Dr. VRAO. Today I am here with another concept in electrochemistry, that is corrosion, right? Corrosion. Corrosion. Corrosion is nothing but a interaction of metal with environment. I repeat, corrosion is nothing but interaction of a metal with the environment. In this context, why metals interact with environment? Why? Because metals occurs in nature in the form of oxides, sulfides, carbonates. Okay. So, metals occurs in nature in the form of oxides, sulfides and carbonates. So, but man for his purposes, for his own purposes, extracting the metal from these oxides. Usually metals occurs in nature in the form of oxides, sulfides or carbonates, which are called as minerals or ores. So, man for his purposes extracting the metal from its ore or minerals. So, we can define that corrosion is conversion, that is natural tendency of metal into its mineral form is called corrosion. I repeat, conversion of metal into its mineral form by the interaction of environment is called corrosion. For example, iron converts into iron oxide Fe2O3 and silver converts into silver sulfide Ag2S, right, and copper converts into carbonates, right, copper converts into carbonates. So, and iron, the conversion of iron into iron oxide is called rusting, and conversion of Ag into that is silver into silver sulfide, that is called tarnishing, tarnishing. Tarnishing is nothing but a loss of lustre, that is loss of glazeness of the compound, that is called tarnishing. Usually we experience this tarnishing in the in case of what is it called, silver ornaments. Usually our silver ornaments undergo tarnishing, that is that silver converts into silver sulfide, right. So, corrosion is nothing but interaction of metal, with environment. And why that metals interact with environment? Because of usually metal occurs in the form of minerals or ores. So, usually metal always try to it always look forward for conversion convert into its mineral form as it occurs in the nature, right. So, that is corrosion. So, and corrosion is electrochemical in nature, and electrochemical corrosion is considered as anodic dissolution of metal, right. I repeat, corrosion is electrochemical in nature, and electrochemical corrosion is defined as or considered as anodic dissolution of metal, where metal acts as anode. Anodic dissolution means what happens at anode? Oxidation takes place at anode. At anode, metal undergoes oxidation, Mn plus n electrons. So, metal undergoes oxidation. This is called anodic dissolution. So, in this anodic dissolution, metal acts as anode. Metal acts as anode. If metal acts as anode, some other substance may act as cathode and forming a voltaic cell. Forming a voltaic cell. We already came across, we learnt voltaic cell where anode and cathode is there. Okay, anodic compartment and cathodic compartment, right. So, in the same manner, electrochemical corrosion is considered as anodic dissolution of metal, where metal undergoes oxidation. Where oxidation takes place? Oxidation takes place at anode, right. So, metal acts as anode. If metal acts as anode, some other compound or some other substance or the same metal acts as cathode, forming a voltaic cell. So, that happens in the case of that voltaic cell is constructed in the process of corrosion, in the process of corrosion, right. So, metal acts as anode and same metal or some other metal or something acts as cathode, forming a voltaic cell. So, corrosion occurs if the environmental conditions favors the formation of voltaic cell, right. I repeat, corrosion occurs if the environmental conditions favors the formation of voltaic cell, where metal acts as anode, where metal acts as anode, where metal acting as anode, right. This is the very important. Corrosion occurs if the environmental conditions are favorable for the formation of voltaic cells, where or voltaic cell where metal acting as anode, right. So, you know voltaic cell where oxidation and reduction takes place. So, this is about corrosion. Let us see the mechanism of corrosion, what happens and what are the reactions. Already we learned that we came to know that corrosion is a electrochemical process, okay, electrochemical in nature, that is it is a redox reaction. So, how what are the reactions, what is the reactions that are taking place during the process of corrosion, during the process of corrosion, right. Okay. So, let us see the mechanism of corrosion, mechanism of corrosion. Right, mechanism of corrosion, mechanism of corrosion, right. So, usually the water vapor on the surface of the metal, usually metals undergo corrosion. So, the water vapor on the surface of the metal dissolves CO2 and O2 in the environment. Okay, I repeat, the water vapor on the surface of metal dissolves carbon dioxide and O2, forming the carbonic acid, forming the carbonic acid. So, the water vapor on the surface of the metal dissolves CO2 and O2, forming the CO2 dissolves in water, forming the carbonic acid H2CO3, right. This carbonic acid acts as electrolyte in voltaic cell. Already we know that voltaic cell formation happens in the process of corrosion. Voltaic cell is constructed in the process of corrosion, right. So, the water vapor on the surface of the metal dissolves carbon dioxide and oxygen and forms carbonic acid. This carbonic acid acts as electrolyte for voltaic cell, and this carbonic acid dissociated to some extent. This carbonic acid dissociates into some extent. That dissociation is like this: H2CO3 gives rise to 2H plus plus CO3 2 minus CO3 2 minus, right. So, this is the dissociation, and when iron, for example, we are discussing the rusting of iron. So, when iron in contact with dissolved carbon dioxide and dissolved oxygen, it undergoes oxidation, because iron, the water vapor on the surface of the iron or metal, okay, that dissolves carbon dioxide and O2. So, iron interacts with the dissolved carbon dioxide and O2. When iron interacts with the dissolved carbon dioxide and O2, that undergoes oxidation. So, that is iron undergoes oxidation, that is Fe solid undergoes oxidation, that is Fe plus 2 plus 2 electrons. This is oxidation E naught. This potential is which comes out to be 0.44 volts. So, this is the oxidation reaction. Okay. So, iron in contact with dissolved carbon dioxide and oxygen, that undergoes oxidation, and this oxidation potential comes out to be 0.44 volts, right. And the electrons lost by iron, are taken up by the H plus ions. So, H plus ions, how can we where we avail H plus ions? We avail H plus ions are there is H plus ions from the H plus ions are formed from the dissociation of carbonic acid. So, the electrons lost by iron taken up by H plus ions. Usually it is represented as H plus ion plus electron, that is a hydrogen atom. This hydrogen atoms interacts with oxygen, forming the water. That is, for example, this interaction can be represented with a chemical equation, balanced chemical equation. 4H plus O2 gives rise to 2H2O. Okay. So, this is the reaction, that is 4 hydrogens. We can more simply we can represent this equation as 4H plus ions plus 4 electrons, 4H plus ions plus 4 electrons plus O2, that gives rise to 2H2O. Okay. So, this is the balanced equation. 2H2O, right. So, this is the reduction. So, these are in this case electrons are gained by H plus ions, okay, and oxygen is reduced. This is called reduction potential, which is comes out to be 1.23 volts. 1.23 volts. So, oxidation takes place, reduction takes place, but reduction of oxygen involves H plus ions. Reduction of, this is the very important point, reduction of oxygen involves H plus ions, that is when pH is high or concentration of H plus ions are low, this that is corrosion of iron, that is iron does not corroded, right. You catch my point. What is that point? Yes, oxygen undergoes reduction in the presence of H plus ions. Oxygen undergoes reduction, and this reduction reaction is in the presence of takes place in the presence of H plus ions. So, H plus ions. So, when pH value is more or concentration of H plus ions is less, iron do not undergo corrosion. Okay, this is the very important point. So, at high pH values of the for example, if iron is placed in solution of a pH whose pH is 9 to 10, then iron do not corrode, because that corrosion process involves reduction of oxygen in the presence of H plus ions. So, in the case of high pH or in the case of low concentration of H plus ions, this iron do not undergo corrosion, right. So, this is the very important point, and the total overall reaction and net cell reaction, that is this is the oxidation reaction and this is the reduction reaction, and this oxidation reduction takes place simultaneously, and the total overall reaction is 2Fe plus 2 4H plus O2 gives rise to 2Fe Fe plus 2 plus 2H2O, right, 2H2O. This is the overall reaction where iron undergoes oxidation and oxygen undergoes a reduction, right. So, this is the electrochemical reaction that takes place during the process of corrosion. Okay, more simply we can write this this reaction can be written as 4Fe plus O2 gives rise to 4H2O gives rise to, or 4H plus ions or 4H2O, this gives 4 or 8H plus ions, this forms Fe2O3 plus 2H2O, Fe2O3 plus 2H2O or 8H plus ions plus 8H plus ions, 8H plus ions. This is the reactions that are taking place at during the corrosion of iron. But Fe2O3, this can be represented as Fe2O3, the Fe2O3 plus X moles of water, that forms Fe2O3 XH2O. This is called hydrated iron oxide. This is called as a rusting of iron. This is the mechanism of a rusting of iron. So, what the point that you should remember is corrosion is electrochemical in nature. So, when the environmental conditions are favorable for the formation of voltaic cell that forms and metal acting as anode, then electrochemical reaction takes place, that is redox reaction takes place, and for that and the mechanism is and the mechanism for that corrosion is in this way we can explain the mechanism of corrosion. Okay, I hope you all understand this process of corrosion. In the next video, we should know types of corrosions and prevention of corrosion. Let us discuss, and in the next video we will discuss the types of corrosion and what is it called, prevention of corrosion. Thank you for watching.